Hello, this is Teresa Adams with the Community College of Denver. What we're going to talk about today is linear velocity. We're going to talk about linear velocity in terms of our angular velocity. We talked about angular velocity in our previous video. Why do we want to talk about linear and angular velocity? Because when we look at our speedometer in our car, our speedometer doesn't give us revolutions per minute. It doesn't tell us how fast our wheels are rotating. In revolutions, it tells us how fast our wheels are going linearly or miles per hour. It's a linear measurement. So that's what we're going to do today is we're going to think about a point in motion around a circle of radius r through an angle of alpha radians. It's important that alpha's in radians in some given time t. Then its linear velocity v is given by v is equal to s over t, where s is our arc length, or in other words, s is our angle alpha in radians times r. T is our time unit. And another way we can say v, our velocity, or linear velocity, is equal to our radius of our circle times omega, and that is our angular velocity. Now, if our angle alpha is 2 pi, then our arc length is equal to the circumference of the circle. In other words, it's equal to 2, let me erase that, it's equal to 2 pi r. So let's take a look at our first one. We have a blade of a windmill. It's 30 feet long, so our radius is 30 feet. It rotates 90 degrees for every 30 seconds. That means that takes, for one revolution, it takes 2 minutes. So, one revolution per 2 minutes. We want to know what its linear velocity in miles per hour is at the tip of the blade. So in other words, that 30 feet is now going to come into play. So we have one revolution for every 2 minutes. For each revolution, the tip of the blade travels the circumference of the circle. So in other words, it travels 2 pi, and our radius is 30. So, and that should be feet, 30 feet. And that's per one revolution. Our revolutions will cancel, and our 2's will cancel. And so I have some unit, I have some measurement in feet per minute, but I want it in miles per hour. So I need to convert my feet, and I need to convert my minutes into hours. So if you live in Denver like I do, you know that for 1 mile, let me erase that. It's not very nice. Let's try this again. 30 feet there. So for 1 mile, there is 5280 feet. So now my feet will be done. Now I'll have something in miles per minute, but I want miles per hour. So I need to convert my minute into hours. There are 60 minutes for every 1 hour. So now my minutes go away. And I am left with the 30 times the pi, or 3.14 if you don't have a pi button, times the 60, and then you divide that by the 5280. And your answer is 1 point, and I'll give it to 1 decimal, or 2 decimal places, 0.07 miles per hour, which actually isn't very fast, and that's okay too. So let's take a look at example 2. We're going to find the linear, that should be velocity right there. Right there should be velocity, so go ahead and put velocity in right there. The linear velocity in inches per minute for a point on the edge of a 6.5 inch diameter record spinning at 45 revolutions per minute. So we have 45 revolutions per minute. That means for each 1 revolution, it's going to go the circumference of the circle, which is, for us, it's going to be 6.5, that's diameter, times pi, inches per 1 revolution. And so we want the inches per minute. So when we do this, our revolutions will cancel, and I'm going to be left with inches per minute. which is going to be the 45 times the 6.5 times 3.14, or your pi button. So in other words, this thing will travel 918.45 inches per minute. And I'm going to let you do number 3 on your own. I'm going to give you the answer, and we'll go over that in class if you have any questions. And thank you very much.